Welcome to Revised Chemistry with Mr. B. In this video we're going to take a look at equilibrium, closed systems and Le Chatelier's principle. A closed system is when the reaction takes place in a sealed container so that the reactants or products can't enter or leave the system. So imagine you've put a couple of reactants together in a conical flask and you've sealed it closed with a rubber bung. Equilibrium is the point where the forwards and reverse reaction are occurring at the same rate, and make sure you learn these two definitions for your exam. It's sometimes called a dynamic equilibrium because although the overall amount of products and reactants may appear to stay the same, the forward and reverse reaction are still happening. It's just that they're happening at the same rate. So it might look like you're not making any more of the product, you actually are, it's just that it's turning back into the reactants as quickly as it's being formed. The rest of this video is higher tier only. In fact, questions about this are aimed at the grade 8 and 9 students, so they tend to appear towards the end of the exam paper. So if you're finding it a bit tricky, that's okay, it's meant to be challenging, just watch the video a second or third time until you understand more of it. So the position of the equilibrium can change. If the equilibrium shifts to the right, more products will be made. If the equilibrium shifts to the left, more reactants will be made. And the position of the equilibrium can be affected by the conditions of the reaction, such as the temperature, the pressure if the reactants are gases, or the concentration of the reactants or the products. Le Chatelier's principle can be used to predict what would happen if you change the conditions of a reversible reaction. And Le Chatelier's principle states that if you change the conditions of a reversible reaction in a closed system, the position of the equilibrium will change to try and counteract it. So whatever you do to the reaction, it will try and undo that change. For example, if you increase the temperature of the system, the equilibrium will change to try and reduce the temperature back down again. If you increase the pressure, the equilibrium will change to try and reduce the pressure back down again. Let's take a look at the effect of changing the temperature. So we can see in this reaction that the forwards reaction is exothermic and the reverse reaction is endothermic. So what happens to the yield of N2O4 if the temperature is increased? Now by yield we mean how much of it is made. Well, it will encourage the reverse reaction because the reverse reaction is the one that cools everything back down again. So if we increase the temperature, according to Le Chatelier's principle, it's going to try and reduce the temperature again, and the endothermic reaction will do that. That means the equilibrium position shifts to the left and less N2O4 is made. And this is a good writing frame for answering these questions. You say, is it going to encourage the forwards or reverse reaction? Will the equilibrium position shift to the left or the right? Therefore, will more or less of the product be made? Keep watching until the end because I'm going to put a link up to another video where I walk you through an exam question to consolidate your understanding of this difficult topic. So what would be the effect of changing the concentration? What happens to the yield of BiOCl if the concentration of BiCl3 is increased? Well, it will encourage the forwards reaction because by doing that, it will reduce down again the concentration of BiCl3. So it will try and undo the change we've put onto the system. So if it encourages the forward reaction, the equilibrium shifts to the right and more BiOCl is made. So once again, we've set it out in terms of will it encourage the forward or reverse reaction? Does the equilibrium shift left or right? And does it make more or less product? Let's take a look now at the effect of changing the pressure. What would be the effect of increasing the pressure on the yield of NH3? Well, first we need to look at how many molecules of reactants are on the left and how many molecules of product are on the right. And we can see on the left we've got 1 molecule of N2, 3 molecules of H2, so that's 4 molecules of gas on the left. On the right we've just got 2 molecules of NH3. So if we increase the pressure, it encourages the forward reaction as there are less molecules on the right hand side. So that will tend to reduce the pressure back again. If we're increasing and encouraging the forward reaction, then the equilibrium shifts to the right and that means that more NH3 will be made. So don't forget to check out that exam question video. Thanks for watching.